All right, let's dive right in. We're going to talk about a threat, one that's totally invisible, lasts for what seems like an eternity, and is silently poisoning our planet's most vital resource. It's water.
So, just to help you wrap your head around the scale of this, let me ask a question. What kind of pollutant can stay dangerous for, get this, over 10,000 years? And no, that's not a riddle. It's the stark reality of the problem we're exploring.
The answer, of course, is radioactive waste. And look, this is a whole different ballgame from things like plastic or an oil spill. We're talking about materials where the very atoms themselves are unstable. They're constantly spitting out this harmful energy called ionizing radiation. It's that instability right down at the atomic level that makes this stuff so fundamentally different and so uniquely hazardous.
Which brings us to the first major idea we really need to grasp. We have to start thinking of this as the forever pollutant.
And you know, when I say forever, I'm really not exaggerating by much. The hazardous life of some of these materials is measured in thousands of years. To put that in perspective, the entire history of human civilization is just a fraction of that time. This waste will outlast all of us.
So, if this threat is so dangerous and lasts for so long, where in the world is it all coming from? Let's take a look. It's actually a lot more diverse than you might think. Yeah, of course, nuclear power plants are a major source, but we also see it from the fallout of old weapons testing, from medical facilities that use radioisotopes for diagnosis and treatment, and even from the very beginning of the process, the mining of materials like uranium. Turns out it's a byproduct of a lot of our modern technologies.
And it's super important to understand that not all radioactive waste is created equal. It's kind of categorized by its intensity. You've got low-level waste, which could be something as simple as contaminated lab clothing. But then you get into intermediate and high-level waste, and that's the really potent stuff, like spent nuclear fuel, which is incredibly dangerous and needs the most secure, long-term containment imaginable.
Okay, so once this material actually gets into the water, what happens next? Well, that's when it begins what we can call its invisible journey.
This is such a crucial part of the story. It's really a four-step process. First, it disperses, right? The currents spread the particles far and wide. Then, a lot of it sinks and binds to particles on the seafloor, kind of hiding in the sediment. But it doesn't just stay there. Third, through bioaccumulation, it gets absorbed by the smallest organisms, like plankton. And this leads to the most dangerous step of all, biomagnification. As we go up the food chain, that radioactivity becomes more and more and more concentrated.
And that invisible journey? It leads directly to a very real and very visible chain of damage.
The single most devastating impact, right down at the biological level, is this: genetic mutations. The radiation literally scrambles the code of life.
So, when we say genetic mutations, what does that actually mean for aquatic life? Well, it means the radiation alters their DNA. This can cause horrible deformities, reduce their ability to reproduce, and lead to problems in their offspring. In the worst cases, it can completely wipe out sensitive species, throwing entire ecosystems totally out of balance.
And of course, that chain of damage doesn't just stop with fish. It leads right back to us. And that brings us to the human health effects.
Because of that biomagnification process we just talked about, this contamination can end up right on our dinner plates. For humans, exposure is linked to a higher risk of cancers, especially things like leukemia and thyroid cancer. It can cause organ damage and, in cases of very high exposure, acute radiation sickness. The risk to us is definitely real.
So, with a threat this persistent and this dangerous, what can actually be done? This brings us to the crucial topic of containing the threat.
Thankfully, there's a pretty comprehensive strategy. Think of it as a multi-layered defense. It all starts with prevention, just stopping it from getting out in the first place. For waste that already exists, there are treatment methods, like vitrification, which turns liquid waste into solid glass. Then comes long-term storage in shielded containers, often in deep, stable underground sites. And holding it all together is strict international regulation and monitoring.
Ultimately, it really boils down to this. You absolutely need proper waste management, strict regulations, and the best disposal techniques we have to minimize this pollution. There's no single magic bullet. It just requires constant vigilance and our very best technology.
So that brings us to the end, into one last crucial thought I want to leave you with. This waste, it's our legacy. It's going to outlast our buildings, our cities, maybe even our languages. So the real question for all of us is, how do we protect the distant future from the dangers we are creating in our present?